Today we'll be discussing the particle model and the journey that an ice cube takes from a solid form through to a melting stage where it becomes a liquid, and then on to when an extremely hot temperature is added, such as fire, to create the mist and evaporation of the water. So here we have some key information about the makeup of a solid particle such as an ice cube. So the particles are not flowing, they cannot move from place to place, but they are vibrating in a regular pattern as they are bonded together. Now, as you can see, our little plasticine balls didn't really like staying in a ball shape, but these are our particles that make up an ice cube, and as you can see now, they are vibrating. So they've got a solid form in an ice cube shape, and shortly the ice cube is going to be melting, which will take us on to the next step of liquids. So our ice cube is now melted into a liquid, and as you can see, the particles are arranged randomly rather than a regular pattern. This allows for more movement between the particles, which then allows the flow of the liquid. Now that our ice is melted into a liquid, we're going to add an extreme temperature. So we're going to actually add fire, and the fire is going to cause the particles to begin moving more rapidly, which is represented by the steam actually, or the vapor, leaving the water as you boil it vigorously. We will leave you with the entire process all linked together. So we originally have our solid, the ice cube's there, sitting there, and the particles are in a structured formation, vibrating, and then they turn into a liquid as they melt. So the particles are not as close together, and they have more of an opportunity to move randomly around each other in a flowing motion, as you can see there in our animation. And once the liquid has been added to a heat element, as we're going to show you shortly, if you can imagine the water's in a pot, we've got the fire there burning away on the bottom of the pot, and the particles are starting to move so rapidly that they're actually leaving the water and becoming a gas. So there then becomes less of those particles as they're rising up through the air in a very vigorous random motion, and they're bouncing around, becoming less and less of them as the water is leaving the boiling pot. And as you can see there, they're becoming less and less as the particles randomly bounce around as a gas. We'll leave you with an extremely useful teaching resource. So we found this BBC KS3 website where it just gives very simplified explanations that you could show to the students regarding solids, liquids and gases. It also just has very simple animations that you can use to show the flow of particles, where there's actually just a carton pouring a liquid into another carton, and just shows the flow of the particles over one another. So it's very highly recommended for a teaching resource. Thanks for watching.